Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the CIGRE 2023 Grid of the Future Symposium. And these interviews are with the leaders at CIGRE and the leaders of the industry. Hope you enjoy. My next guest is Marianna Vaiman. She is the CEO of V&R Energy. Marianna, thank you so much for joining us. I ask everybody this. How did you get started in the engineering world? You're a W, right? Yes. I'm a mechanical engineer, but engineers are certain breeds of people. We think differently. But what got you to get, hey, I'm going to go into engineering and then I'm going to go into the power industry, which is not a very sexy industry back when I was in school. A lot of people were going into power electronics and control. They weren't doing power energy. How did you get involved in the power energy industry from an academic standpoint?
I see. First of all, thank you very much for inviting me to speak. Second of all, that's a very easy question to answer for me.
Okay.
My dad was a power systems engineer, and from very early age, I would hear energy function method, phase angle, control actions, generator control, and I had no idea what it was, but it sounded so fascinating, and he was really passionate about his job, and that passion is contagious. He loves what he does, and that's how I decided to be a power systems engineer.
Like father, like daughter. That's a great story. V&R Energy, tell me a little bit about the company and what you all do.
V&R Energy is a technology provider. We're software experts, and we help utilities and ISOs and regional organizations address resiliency and stability and reliability needs that they have. Real-time situational awareness, how to better monitor microgrids. We're working right now with ComEd in Chicago to have situational awareness and real-time monitoring of their microgrid, for example.
Okay. So I want to appeal now to your expertise of the industry as a whole, okay? Yeah. And so I'm going to describe it. I'm going to give you a number of things. You pick any one of them, and then let's solve it as a problem. We have been living with a grid that started, you build big generation, you send it down big pipelines that were called transmission grid, and you get it down to distribution. And for the most part, it was a stable environment. Today, generation is not just the way it was. We're closing down old line generation. We got renewables coming up. Now even the transmission network is having to change to adjust. At distribution level, you've got ratepayers that are now consumers. You just have a lot of change, both in the technology, and we tell you here, we're at the grid of the future at CIGRE, right? And what we have to do is we got to make a reliable grid. We got to make a flexible grid. We have to harden the grid. We have to get rid of all the 3Ds, decarbonize, decentralize, digitalize. I mean, it's just the changing world that we're in the power industry, which is exciting. That's a lot of change. Opportunity for V&R, because change is opportunity for the engineer. Pick any of those and talk about some areas where you see either great progress ahead or problems that we have not overcome. Where are the points along there that you would just like to pick on and say, hey, let's talk about this? Pick one.
I'll pick several, but they're all...
Pick one at a time, but you could.
They're all related.
Okay.
Tomorrow, we'll have a panel on blackouts.
Okay.
We'll have an opening panel for day 2 on blackouts. And as the grid is changing, and grid has been changing always.
Yeah, right.
But right now, it's much faster pace of rate of change that we are seeing. So we, as the power systems engineers, have an obligation to the society to keep the lights on. This is our major line of business, right? And with all the IBR, inverter-based resources, coming into play with electrification of the society.
Yeah.
With the power system, with these two factors becoming much more stochastic and less predictable in the future, with lots of security concerns, both physical and cybersecurity, with a completely different shape of load growth. Usually we can predict based on demographics how the load would change, but now we see load centers, huge loads appearing where they are not supposed to appear. How to plan and model that. So there are lots of different players right now coming into not only future grid, but also in the present grid. So how we maintain stable operation, because stability is crucial for preventing blackouts. So two of the major phenomena affecting blackouts are voltage instability, voltage collapse, and cascading outages. So how do we predict better? How we analyze it better? How we, if they happen, how do we mitigate and reduce their impact? So I think that would be my area.
Okay. So you see all the problems that we've got, and you said how do we do that? How do we mitigate it, do you think? What are some of the things that are coming online in terms of solutions or things that you've seen? Because one of the things about CIGRE is you get the sharing of knowledge of what works here, right? You get sharing a lot of solutions type things. What do you think some of the mitigation strategies are going to be? And in your expertise is software within that system, right?
Yeah.
So talk a bit, which is data, which is the transfer of data, and the interface. So when you say software, there's a lot about that, right? Talk a little bit about how data and knowledge and all of those are going to be mitigators of those problems.
So data, knowledge, people. So I think number one, and that's not in the order of priority.
Okay. Right. Just having me in first of mind.
Okay. We need to have workforce, and we talk a lot about it. But I think the key is not just to have workforce, it's to have qualified workforce. And I would accent qualified. So that's, I think, one of the keys to our successfully addressing these challenges. Second, looking at more interdependencies, not only power system, but of our networks, but also telecommunications, IT-related issues, interdependencies with the gas system, interdependencies with some of the security aspects. So the not having just one dimension, but having that multidimensional view on multiple systems at the same time and understand their impact on each other. Better coordination between transmission and distribution. We see the lines blurring. We see reverse flows from distribution into transmission, which we did not see before, but with the renewables and DRs, we see it more. So how to better model and represent two systems together. Also, things are happening much more faster now with the electronics-based sources. So real-time situational awareness, synchrophasor-based technologies being used, point and wave, and that's also like where I have specials, but I think they're becoming extremely important in the current climate that we have. Better understanding weather patterns, because we see extreme weather events more frequently. So how to better forecasting, weather forecasting, load forecasting, etc. You also gave the response to your question, data analytics, big data analytics, how do we use artificial intelligence, machine learning, pattern recognition to help us make better decisions and also faster decisions. How do we move to very fast automated controls? So that would help us.
And all of those things are going to require, as you said, qualified. Two unqualified workers do not make one qualified worker. So the idea that we're bringing more in at a time where we are losing more quality people, the brain drain from the boomers leaving the industry has just been tremendous. I retired 3 years ago. I'm not part of the brain drain, but I'm part of the brain drain. We've just lost so much expertise along the way. I don't think we have replaced it as fast as we're losing it. So we have to depend on automated thinking, automated systems. The machine's telling us what's wrong. So we went from time-based to condition-based, right? Once again, it's data flow, data analytics. I think utilities are hiring more data scientists than they are EEs because they need data scientists, right? You're going to do a commercial now for V&R Energy. Talk to me how does V&R Energy fit into all of those equations? What can you do for the industry, for the utility as a provider?
We're taking a lot of this data. We don't take all of the data, but we take a lot of this data, for example, synchrophasor data, SCADA data, state estimator data, and we create tools that allow to make better decisions. Tools like prevention of cascading outages.
Yeah.
You would go to a control room, let's say at ISO New England, and you would see an online cascading analysis tool that V&R Energy developed and worked for many years with ISO New England to have it deployed in the control room so that the operators have better visibility of their system and understand the behavior of the system and the health of the power system better in order to make more informed decisions. So I think V&R Energy, like many other companies in the technology space, are focusing on providing the solutions, the platform for engineers and for operators to make better and faster decisions to preserve stability of the grid and to operate more reliably.
It's one of the things, what you just described is a way that we deal with the brain drain, because we're not going to replace all of them. So you have to give the ones that are left decision-making tools so they can make the decisions, better decisions, faster, because they don't have somebody that can pick up the phone and call right next to her who's been doing it for 30 years and say, hey, I'm suffering this consequence. What do I do? Now you've got an automated system to help you do that. That's brilliant. Last question for you. CIGRE. What do you value about CIGRE, and what have you, where is CIGRE going in your life? Because I know you're an important part of the U.S. National Committee. All right. So talk to me about CIGRE.
Thank you for asking this question. I am a part of the CIGRE leadership team. So with this responsibility comes a pretty significant time commitment.
Yeah.
And I really enjoy volunteering for CIGRE because I think it's extremely important for us not only to do our day jobs, but also to make sure that we have the forums like this, like Grid of the Future, where we can share ideas, where we can learn best practices. And I'm here to learn. So, and many people here are to learn and understand better what are some of the challenges, what others are doing to better solve those challenges, what are some of the ideas that I can bring back to my company, what are the ideas that I can share with others. So I think these collaborative forums like CIGRE are extremely important. One important aspect of CIGRE is that it's based on the country. It's based on the national committees.
Yeah.
And we in US do wonderful things. We have cutting edge technologies and processes and a lot of regulation, which helps us. But many countries are experiencing very similar issues.
Yeah.
Cybersecurity everywhere, and inverter-based resources behave certain way regardless of geography. So it's very important to learn from other national committees and their members what they're doing and try to see if they're ahead of us and implement some of the things.
Well,
yeah.
I bet you don't only value CIGRE for coming and learning. I bet you teach here too, because you know things that other people want to know, so you get to share that. That's one of the things about CIGRE is a very giving organization, because when you learn, you're taking. So when you teach, you're giving. And people can't learn if somebody isn't teaching. So thank you for your commitment to CIGRE, and thank you for your support for what we did here, because you were the person that helped us get this all organized.
Thank you. And like this interview, it's a two-way communication. Of course, CIGRE is always two ways. Otherwise, it does not work. So you share and you learn, and it's a wonderful process of growing professional.
Excellent. Marianna, thank you so much.
It's a pleasure.